I am R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we are going to discuss the topic waves between parallel planes for the unit guided waves. So, what do you relate from this? So, we have a wave. So, a wave is a disturbance of one or more fields such that the field values oscillate repeatedly about a stable equilibrium. There are two types of waves. One is mechanical wave and another one is electromagnetic wave. So, the electromagnetic waves are also known as EM waves. They are produced when an electric field comes in contact with the magnetic field. They are the composition of oscillating electric and magnetic fields. So, these are obtained from the solutions of Maxwell's equations, which are fundamental equations of electrodynamics. And now we are going to discuss the topic the electromagnetic wave propagation between a parallel plane. So for this analysis we are taking two parallel planes separated by distance a in x-axis, and the plate separation is in x-axis, and the plate length is in z-axis, and here the P is represented the direction of wave propagation. So according to this example, we have taken the direction of wave propagation is in Z direction. So now we have to determine the electromagnetic field configuration in the region between the two parallel planes. So for this, the Maxwell's equations should be solved. We have to use appropriate boundary conditions in this analysis, and we know the two Maxwell's curl equations for these parallel planes. One equation is del cross H is equal to sigma plus j omega epsilon E. Here sigma is the conductivity. This is made 0 because the distance between the parallel plane we have taken the medium is air medium. And the second Maxwell's equation del cross H is equal to j omega epsilon E, and another one is del cross E is equal to minus j omega mu H. So the boundary conditions for perfectly conducting planes: tangential component of electric field is 0, normal component of magnetic field is 0. So the wave equations are del squared E is equal to gamma squared E and del squared H is equal to gamma square, where gamma is the propagation constant. It is square root of sigma plus j omega epsilon into j omega mu, and here the sigma is 0 because the medium is air between the parallel planes, and so the gamma is root of j omega epsilon into j omega mu. So by taking square root we get the value j omega root of mu epsilon. So in rectangular coordinates we are taking the Maxwell's first curl equation del cross H is equal to minus j omega epsilon E. So this is expanded, we get three equations, and in these three equations next we are going to make some assumptions. And similarly del cross E, the Maxwell's second equation is taken, and from this also we can get another three equations. It is 4, 5, 6. So we got two sets of equations, three equations from first Maxwell's equation and another three equations from the second Maxwell's equation. The propagation constant, we know it is a complex quantity. It is alpha plus j beta. If gamma is real, we know the alpha have value but beta is equal to 0. So this represents there is no wave motion because the phase constant is 0, but only an exponential decrease in amplitude because we have the attenuation constant. And suppose if we take gamma is imaginary, this represents alpha 0, that is no attenuation. Since beta have value, we have wave propagation. So for all wave propagation we have to choose the second condition, because the second condition represents the wave propagation without any attenuation. So now we are making some assumptions in order to simplify the further analysis. So in y direction, the plate is infinite in extent, the parallel planes. So if the planes are parallel planes, we consider the field is uniform and constant. So if the field is uniform and constant, its differentiation is 0. So in y direction, dou by dou y is 0. And in x direction, there are certain boundary conditions because the parallel plane boundary is in x direction. So we cannot predict or we cannot make any assumptions in x direction. We have to get the x value from the analysis. So dou by dou x, there will be no change. And in z direction, the wave is assumed to propagate. So in the variation with the z direction, we are substituting the propagation constant minus gamma bar, and dou by dou z squared is plus gamma bar squared. And after substituting the assumption, we get another new set of equations. It is marked as 7, 8, 9, one set of equation, 10, 11, 12, another set of equation. So in order to get the final field equations, these two sets are simultaneously solved, and the final equations are Ex, Ey, Hx, Hy. These four equations are given. Here h squared is gamma squared plus omega squared mu epsilon. So conclusion, in equation 12 and 13, we have the component of Ez, but no component of magnetic field, that is Hz. So these waves are called E waves or transfer magnetic waves. And in equation 14-15, there is a component of magnetic field in Z direction of propagation, but no component of electric field. These waves are known as H waves or transverse electric waves or TE waves. Assessment: the direction of electric and magnetic fields of an EM wave assumed to propagate in y direction. So when the wave is propagating in y direction, its electric and magnetic field must be in x and z directions. References. Thank you.